So, Zicklag, I think you also have some experience with WASM and exporting to the web, right?
Yeah,
Did you? When we talked about this just a second ago, I thought with the conversations about Lua and all these things, did you also run already into issues where you wanted a much like a legacy sort of C library or something and wanted to run it inside a project too? Because it sounds like it should be trivial to connect those two together now with everything you did there.
yeah, no, that's absolutely a challenge because it's like you have these C++ programs and they run in the browser and they compile to WASM and that's great and Rust does too and you'd think you could use them. But the problem is that WebAssembly doesn't have a linking standard yet. It's something I've looked a lot into. It looks like they're moving on to the component model maybe instead of a like a typical like assembly linker like LD or something like that we would normally use. So basically, even though you could create a WASM binary for the C++ program, you create a WASM binary for your Rust program, there's not a way to link or resolve the symbols to the C++ library from the Rust WASM library. So you're in kind of a sticky situation because the only way to get to them then would be to like traverse through JavaScript. So from Rust
Oh
WASM to
yeah,
JavaScript to the other WASM and back, which is it kind of defeats some of the performance advantages of the WASM for one. Um,
yeah.
so there's like Emscripten is the only solution I've seen so far. If you opt out of WASM 32 unknown Rust target and you use the Emscripten, and Emscripten has a way to do some sort of linking
Hmm.
using their custom WASM ABI or something like that. So that's the solution I've heard is basically you have to use Emscripten if you want to link a Rust WASM to a C++ WASM, which apparently is they've been doing it for a while, so it does work. For
Hmm.
us, it was just like I want you just to build a clone our repo and just build it for web as easy as possible, as rusty as possible. So that's why, because we were looking at Lua implementations, right? And like, there's obviously C++ Lua implementations um,
Hmm.
that we could have maybe used. There's ports bindings to JavaScript and all of that, but then it wasn't going to be easy to link to Rust. So the solution was find someone who rewrote it in Rust too. So yeah, unfortunately, that's
There's always someone.
the WASM folks haven't figured out how to make that smooth. It looks like they'll have it one day, but yeah.
Yeah, that sounds like a whole different conversation. I actually managed now that you mentioned it, I actually managed to get a Rust-based Emscripten dynamic library with the old Godot 3.x Rust bindings that we had to work with the web exported Godot game. That was
Oh
a
wow.
nightmare, and I didn't want to maintain that ever. It was more like, cool, it's possible. Okay, I move on now. But
Yeah.
yeah, we certainly need something to make these things be able to talk to each other. That's a real shame right now. Um, yeah, Thierry, do you have any experience with the web, especially now that you're working on Rapier that has a significant
Oh,
web export?
no, I won't go into detail for that, but I was thinking about the CRABI. Is that something that's relevant there? The
The what?
the CRIABI. It's yeah, it's a ABI for Rust.
Um, it's so the closest thing we have right now is actually the component model, which Rust actually recently started to add support for the new WASI preview 2
Mm.
or whatnot. So that it's still like stabilizing and stuff like that, but that lets you build the WASM components that can export things to other WASM components. So that is actually getting some traction soon, and I think that's why they have postponed a typical linker is because they're moving towards this component direction instead of that. So we might be able to actually do that. We might actually be able to do that today if you got the C++ library to build to a WASM component. So
Mm.
that's actually something to look up. I was looking at using WASM components for something totally unrelated at some point and didn't get totally into it.
Hmm.
But so that that might actually work because basically once you built a WASM, it has to be totally supported by the WASM ecosystem. Otherwise, or somehow working the C++ build into Rust C or something like that. So I don't know of any ways to hack that in. But hopefully components might make that easier. That might be possible today. That could be interesting.
Okay. That sounds like a talk for the next time. And it is somewhat related. So I'm asking you, Jillis, are you also planning eventually then, once everything is working and is awesome, fast and safe and all, to also write a C API so that the rest of the world can benefit from this as well?
I mean, if it's actually better, then yeah, we should do it, right? But there's still a long way to go. And I still have to look into it, like what kind of tools does Rust provide to create that kind of C interface. I hope it's not as bad as this 10K lines of code that they have the C++ version.
I think
I think you will get a 10K auto-generated file.
Yeah.
Yeah, I don't know what there is for auto-generating, but as far as, I mean, if you go to C API, C is super kind of simple. I mean, obviously you got pointers and danger and all that stuff, but I've seen other Rust crates have C. You can do it in like totally separate crate, which is nice because you basically just need to make your extern C functions so that other people can call it, and then you call all your normal Rust functions on the inside of that. So it seems like at the very least you could have some. It can be like kind of maintained independently, or even at a different quality level or whatever. So it seems like something that's real possible for someone who's interested in or savvy to that too, if they wanted to like adopt it or something like that.
It's definitely possible, but it's a little bit more complicated as soon as you want to do types between the boundaries, right? And I'm pretty sure Jillis doesn't want to write C represented types all the time for the core library. So you might end up having to have like wrapper types around it and stuff. But yeah, it's definitely possible. I mean, there's a bunch of examples for that, right? And I mean, I assume Rapier has to have some sort of similar thing as well to get out into JavaScript, right?
Yep.
Yeah. Speaking of Rapier, Zicklag, what kind of physics solution are you using in Bones?
Oh yeah, and so like, but right now for physics we mostly dish that off to the games, or so you can use whatever makes sense for your game. We might be able to pull some of what we've got for physics and Jumpy. We're just using Rapier, but we've got like a funny combination because we got like obviously kind of a very specific like 2D physics that we're going for. So we run the Rapier like physics and collision pipeline. So it generates the collision world and optimizes raycasts and all that stuff. And we use mostly the collisions during the normal gameplay. And then when you go into like ragdoll mode after the player gets hit with a sword or something like that, then we turn on the dynamics for that player so that they bounce around like a ball. So it's kind of a combination where most of the logic, we're kind of mostly doing manual logic for what happens when you hit jump, how does he handle when he touches walls and sliding and all of that, because it's very simple, mostly just sliding boxes around. But then it's fun, it's very cool because the Rapier, it was mostly raycasting based, if I remember right, as far as how we don't make sure you don't go through walls and all of that stuff. We're just using Rapier raycast, and it handles making that performant, keeping the colliders up to date. So we've got basically this synchronization layer there, and then but very handy just be able to say turn on normal physics and have them bounce around. So and that's something we might get to use more for different effects throughout the game. It could be fun.
Interesting. And is that because you mentioned it's heavily networked and rollback and all of that? Is that does that apply to these ragdoll animations? I assume not. That's basically like, okay, he's killed, so the rest is now just like
no. Rapier actually is great. It's one of the few physics engines that has a deterministic mode. So you can tell it's slower. You tell it to go. I'm pretty sure most of what it does is it just makes sure it uses software implementations of certain functions like tangent and sine, and I think they're called transcendental functions for some reason. But anyway, use the hardware implementations can differ on those functions. But the hardware implementation is faster. You could just pass the feature flag to Rapier, and then it will use the software implementation that will run the same on any platform that supports the float standard or whatnot. So that's really handy for us because that's a lot of the reasons you couldn't like do a rollback mode for like Godot or Unity or Unreal and stuff like that. A lot of the limitation comes to that physics engine not being deterministic. So that was really handy for us. Rapier was a big win there.
Nice. Yeah, that's cool to hear. Yeah, I think that's really one of the USPs of Rapier. As you mentioned, it's pretty unique to support that deterministic physics there. I think I just recently read a blog post by the Box 2D guy about how the old Box was not supporting that, and what efforts he had to go through to actually support that in the 3.0 release. So that's it's still an interesting topic, like what you have to do to make it really solid across platforms. Jillis, I thought about you also must have gone through similar issues as what you pretty much usually solve with the physics engine, right? Like in terms of finding collisions, is there a straight line between you and the audio source and stuff like that? Are you using any of the existing crates, or do you really just translate Steam audio one by one and they're doing this themselves?
No, so for that I use Perry. I was able to save 700 lines of code by using that.
Yeah, okay.
And yeah, I mean, it's like using Perry in that sense, very simple. So I could also easily swap it out, maybe with something land-based in the future, hopefully. I think that would be nice.
Yep.
Yeah, the Rapier, one of my favorite things was how it kind of like Bevy, you can pull it apart into pieces if you need to. So it's like Perry is just the collision detection. It's the very raw math function collision detections, or the collision pipeline or the physics pipeline. Because we actually started off in Jumpy just using Perry. And then we wanted, as we needed to optimize it more, it just became easier to layer on more Rapier. So, but that was very handy.
Oh. So that's building in the other direction in comparison to Bevy.
Exactly.
Yeah. If anyone in the audience wants to know more about Parry, the documentation is a bit difficult to parse, but I recommend to go to look at nCollide, which was the ancestor of Parry, let's say. And yeah, there is a way more digest documentation on nCollide.
Cool.
Okay. And it still applies to the algebra,
yep,
or
mostly.
Okay.
Yep.
Cool.
It's the whole Rapier stack was built on algebra, and there was it dates back to 2015. That's Rust 1.0, and then there was algebra, which is mathematics. Then Parry for collision detection. Then there was nphysics in 2015, and then nphysics. Just this block was rewritten in 2020 for performance reason and organization. So yeah, and nCollide was before Parry, but it was just rebranded, and most of the code is quite similar.
Okay. So you one day will copy over the documentation as well.
Yep.
Nice. Okay. There's actually an interesting question in the chat that I think is very perfect for a panel like this. Like, what do you guys think is the best first engine to learn for a new developer? I guess in the Rust space.
Well, Bevy is easy to get started with, and right now Bones is not ready for Bones. To be clear, has plenty of rough edges. So I haven't tried Good Game Easy though. So I mean, mostly all I've tried is Amethyst, which is superseded by Bevy, and Bones, which I'm in the middle of making and isn't ready yet. No, and so but no, we actually have and we got some good feedback recently from new guy who is trying or who came in, found Bones. He was comparing macro quad and stuff like that, and
Yeah.
Bones seemed to fit his use case for the networking perspective, because that he wanted to do like local type experience except online. So and he confirms, yes, it's it's rough around the edges. It needs some help, but it's good to get someone else also using it, so it's not just like the insides of Jumpy outside of Jumpy. And so hopefully we'll have he's got good ideas and stuff on how to help bring that in. So hopefully we're going to have some more influence on refining it a little bit, making it easier to use, and just having other games as a reference for, okay, what do different games need to accomplish? What kind of different use cases do we want to help make easy? Because Bones is very much focused on the make it work for a real game first, then make it easy. So the Hello World in Bones is harder than the Hello World in Bevy, but it's a lot similar too. So probably easiest, especially with all the resources around and stuff like that, to get into Bevy first. But if you're willing to experiment with something a little bit different, and then Bones is there, and I don't have much experience on anything else, so someone else would have to speak for it.
Yeah, it also depends on how comfortable you are with ECS, or comfortable to try ECS. If you're more from a background with traditional game development, with the update loop, with simulation, rendering, probably I've started. I've used a bit GG Easy before Bevy, and it was great. So try it out. And MacroQuad is also a strong choice there, and especially for its we were mentioning compile times. MacroQuad is very, very light. Yep.
Yeah, actually, I know I know at least one developer who had mentioned not liking the feeling of being restricted by the framework of like ECS and stuff like that in general. MacroQuad, I haven't used it much, but it definitely seems very light on that, very easy to just get stuff drawing. So probably one of the more fun to play with, even if maybe I'd use something else for once the game needs to get fleshed out more and such.
Yeah, I think macrocode is really more like the rendering module of Bevy in a sense, but not using web GPU there. So, Jillis, what's your opinion? Oh, sorry.
Oh no, continue.
Okay, so yeah, I've only used Bevy, and coming into Rust and ECS at the same time, it's pretty difficult. But I think for me, I really believe in the ECS. It's a great way to build games that are easy to make bigger, and so in that sense, I would go for Bevy or something ECS related. Yeah.
Yeah. The only thing I can say to that, I don't want to really go into the whole this engine versus that engine, but the layer about the ECS topic, I think what's really surprising to me is that I talked to a lot of people in the Bevy community, and it's the first time, I think, where I'm talking to people using Rust as like the second reason. They are coming to the Bevy engine because they were looking for something that is totally natively ECS driven. And then they learn Rust because it is requiring them to be aware of Rust. And the fun experience of those people is that they learn a very kind of different Rust at first. It's like the easy mode Rust when you're coming with this ECS entrance, right? You basically don't have to worry about borrow checker and lifetime stuff anywhere because you have nice integer indexes into stuff. It's pretty much shielding away especially in the first phase, what kind of intricacies you are exposed to when you're suddenly going deeper, and you have to look behind the curtains. So I think it really depends on also what background you come from, right? Some people are really hyped about ECS, and they are tired of waiting for a proper solution in Unity and looking around for alternatives, and they end up with stuff like Bevy, and then they actually at first think, well, this whole rusting is not as hard as people say, until they have to break out of it in terms of the world that Bevy presents at first. But yes, that's just an interesting observation that I didn't expect before digging that deep into the Bevy world.
Yeah,
that's something I definitely noticed when I started doing my Steam audio stuff. It was also my first time like actually really writing Rust stuff. At least it felt like that way.
Yeah.
Oh, that's interesting.
Zicklag?
Yeah, I saw or I read like the talk by Kyron from Chucklefish about the ECS, how it was similar to the almost like the old games where you had to line everything up in memory and you only had so much memory, and then you would operate on that memory and just use indexes into it type of thing. Coming from like not having made any real games or anything other than teeny tiny demos before, the ECS, I was like, it's the answer to all my object-oriented problems. Because there was always this problem where object-oriented tended to work great if you knew everything about everything before you started writing the code. But the fact of the matter is you find out, oh, that's not fun. Oh, you need this now. And you couldn't grow it, which was really frustrating. The ECS seems kind of like this great balance between it's dynamic in that you never know what components are going to be on an entity, but it's static in the fact that, if you got that component hasn't changed. Or that component is static. So it's kind of like a good balance between static and dynamic typing, which seems to be appropriate for games. But then I think also people will be like, you'll try to shove everything into the ECS. And then sometimes that's not the easiest thing to do because it's not necessarily fitted for everything. And it's okay to have a resource that contains like this collision bounding hierarchy, cache and stuff like that. Like it's okay to have these big resources. It doesn't all need to be on the ECS or stuff like that. It's kind of just it's always a learning process figuring out what to use where. Sometimes not the same tool for everything works. Obviously we have multiple tools. So, but
I mean
definitely.
that's the general wisdom, right? Don't make everything a nail just because you love the hammer.
Exactly.
Let's maybe finish with the last two questions. Zicklag, to the uninitiated, how does Bones schema compare to Bevy Reflect?
It works a lot the same. If you're used to box Dynany, Bevy Reflect is probably a little more familiar. Because we had to have a stable memory layout, like you can't just have a dynamic vector. You have to have an SVec or a schema vect. So because the vectors in Rust can't store any kind of type that hasn't been in Rust before. So we have it, whereas you'll access everything in Bevy Reflect through traits, like you'll get like this Dyn list or a Dyn map object in Bevy's or Bone schema. You get like a concrete SVec struct or a SMAP struct. So it's kind of almost a superficial difference. It's in a lot of cases, but it gets different when you try to do scripting maybe, or you integrate with more native stuff. So really
so you see
it's very
boundaries
similar.
So you see boundaries with Bevy Reflect that you don't have in Bones?
Not boundaries until you want to mess with the pointers directly, maybe.
Okay.
So
no one wants that.
yeah, no, it's more like honestly. So I wanted to make a scripting solution that I wasn't afraid the scripting interface was going to be a performance problem. So with Bevy Reflect, you have to keep calling those reflect function pointers. You get a Dyn reflect, right? It actually points to this thing that says, here's this function pointer for listing the items in the vector. Here's this function pointer for this, and it could be different every time. You couldn't. We still have to do that for a couple things, maybe like vectors and stuff, but you don't have to do it with structs. You get a pointer to the struct, and then if you cast it in C to a type that matches, then you can just access those fields just like normal C struct. So again, I'm not sure in real life whether or not that prevents performance problems you would have with Bevy Reflect or not. But at the very least, the hope was I was just going to start with the simplest thing I knew that I could make work, and that if we needed to integrate with a Lua just-in-time compiler that had fancy ability to directly access C function pointers, then, or not function, just C type data pointers and stuff like that, that it would just be able to access it as fast as possible, like we didn't have a scripting interface in the way or something like that. So that was the hope. But really, as far as you want to use one or the other, I guess you'd have to try it and see if you like one more than the other. I think a lot of the differences are probably superficial. Again, unless you're literally wanting to cast these pointers and you have the schema and trying to get an extra performance gain out of that.
Okay. I mean, that's definitely something time will tell in the end, right? Once we have a more solid scripting solution on Bevy side to really be able to compare that.
Yeah, that would be interesting, actually.
Yeah, definitely. Jillis, last question for you. Have you looked into using actual C++ bind gen? The people at Embark used it for physics in the past. Because I think this is related to the beginning of your presentation when you were still using the Steamworks, the Steam Audio C++ SDK, and you mentioned, I think, that you were using it via a C API, right? Which is already like an indirection on another indirection.
Yeah. No, I was just using these crates that other people made. Honestly, at the time, I was very new to this stuff, so I didn't really explore in that direction very much, because all I knew is that these two crates that I was using, I was taking like the working parts of each, and it was still a bit painful, to be honest. So that's why I quickly wanted to kind of move away from that.
Yeah. Anyone interested in that? I think. Sorry.
How long have you been working on the? How long ago was it that you were trying the audio, the initial bindings?
I think it must have been like almost a year ago by now. Yeah.
Okay, cool.
So like even before it got open source, I was already using it and trying to integrate it. Yeah.
Oh, cool.
How did that work when it was still closed source? Then it must have been basically only C bindings that you could use to it, right?
Yeah, exactly. Yeah. And I think they also recently added support for like doing static. I don't know. Like right now, you have to dynamic link your libraries.
Yeah.
It's also very annoying. But I think they recently added support for static linking as well.
Oh, that's nice.
Might help out. Yeah.
Okay, I think that's the end of our questions here. Is there any last comment or a question maybe from you guys towards each other?
No, I think that's good.
Thank you for socializing. I can't read, but yeah, it serves as a teaser.
Nice.
Okay.
Is that like an activity card?
Yeah, I have my first prototype printing.
Oh,
wow.
Awesome.
So yeah,
cool.
I want a t-shirt as well.
What?
I want a t-shirt as well. The Bevy t-shirt.
For the cards, yeah.
No, there is there is a Rust meetup at Paris in which I will be showcasing that.
Oh, a Rust meetup, did you say?
Yep, at Paris.
Nice.
In September 24th, if I recall correctly. Yep.
It's a bit too far. But yeah, I'm curious to hear what kind of reactions you get there, and obviously to see the whole collection of cards.
It will come.
And then I assume next Game Jam, the web version on itch.io.
Maybe.
Okay, guys, it was a real enjoyment to see all these projects and how they are going along. I think it's very inspiring to see what people are doing in these different areas. I mean, it couldn't be more different almost in the terms of presentations that we had today. And yeah, it's also cool to do these cross project kind of presentations, because I think it's super valuable to see what happens on any of these Rust game projects or game frameworks, right? And this is a shout out to anyone in the audience if you guys are familiar with the Fyrox engine. That's probably one of the bigger Rust game engines out there as well. Then definitely reach out to me. I would love to have like a little showcase or show off between Bevy and Fyrox in a future meetup as well. Okay, guys, thank you so much. I will close this stream out now, and I'm excited to see not only Thierry but all of you in follow-up meetups again.
Yeah, for sure. Can't wait.
Okay, guys. Thank you so much.
Thank you.
Thank you. Bye-bye.
Okay, so this was the sixth meetup. I don't want to keep you any longer. It was a pleasure. Thank you guys for joining, and find us on rustunit_.com on YouTube to subscribe, to see the recordings later. I especially heard in chat that we had problems with mono, stereo kind of stuff of Jillis presentations. I'm pretty sure this will be fixed in the recording, because it's going to be having all the audio channels, and I'm going to be able to upload that in HD. Yeah, if you're not subscribed yet, go to bevygamedev.com to subscribe and join the meetup to not miss out on any of the future events. And oh yeah, we are also hiring at rustunit.com, so please reach out to me. And yeah, see you next time.